Assalamualaikum warahmatullahi wabarakatuh. I am Anas Hakim bin Osman with two of my fellow teammates, Muhammad Khairul Amirin bin Bahari and Akil Zafran bin Hassan Basri. We are the Nabila elites from Sekolah Menengah Sains Tukatullah are going to present to you about the sun. What is the sun? The sun is basically a huge ball of hydrogen and helium held together by its own gravity. About 4.6 billion years ago, a giant spinning cloud of gas and dust consisting of ionized neutral or molecular hydrogen called the solar nebula collapsed under its own gravity, flattened into a disk, and pulled towards the center, forming our sun. Other than providing us with the light and necessary burning temperature, what do we know exactly about this megaball? Consisting of 6 regions, the internal regions are the core, convection zone, and radiation zone. The outer region are photosphere, corona, and the chromosphere. The first region is the core. It is made of hot dense plasma and is also the hottest part of the sun, consisting 27 million Fahrenheit. A process known as hydrogen fusion occurs here. The energy released to heat the above region is not enough to fuse hydrogen with helium. Moving on to the next region is the radiation zone. This zone extends outwards from 25% to 70% of the radius of the sun. The temperature falls from 8 million Kelvin to 2 million Kelvin over the distance. The density is about 30 grams per centimeter cube at the innermost layer of the radiative and 0.2 grams per centimeter cube at the top of the radiative zone. This layer just lies outside of the core, where radiant energy is transferred from the core in the form of photons. In this layer, photons bounce off other particles, followed random paths until they enter the convection zone. At the convection zone, the energy is more efficiently transported by the rising and sinking of the gas under the process convection, where the zone gets its name. Hot gas is less dense than cold gas, causing the heated material rises to the surface, the cooler material to fall back into radiative zone. It will take 10 days for the ionized gas to surface to the convection zone. The ionized gas then travels at 1 km per second. Thus, we will move on to the fourth layer of the sun's region. Photo stands for light. Thus, at this region, the photosphere is known as the sphere of light. It is the layer where most of the sun's energy is emitted. It takes only 8 minutes for sunlight from the photosphere to reach the earth. It is a thinner and cooler layer near the sun's surface compared to the other layers. The density of the material inside the sun is thin enough to allow light shine through. This is that we can see while we look at the sun. The temperature falls around 6,000 Fahrenheit to 11,000 Fahrenheit. The energy from inside the sun is free to travel into space. Next is the chromosphere, the fifth layer from the core sun. It is an irregular layer above the photosphere. The temperature is so hot that it can rise from 6,000 Celsius to about 20,000 Celsius. During the solar eclipse, this layer will appear bright red. The hydrogen is the one that emits light that gives off a reddish color. The color brings the name of the zone. Chroma stands for color, producing the name chromosphere. The corona. The corona is the sun's outermost layer. The temperature is higher here and can raise upwards to 2 million Fahrenheit. This region is 1% less than the photosphere. However, this layer can only be seen during total eclipse. It is hundreds of times hotter than the sun's surface. Corona mass ejection. CMEs are large explosions of plasma and magnetic field from the sun's corona. They can eject billions of tons of corona material and carry an embedded magnetic field that is stronger than the background solar wind interplanetary magnetic field (IMF) strength. Corona and solar winds. How does corona produce solar winds? Corona extends far into space, and also corona's high temperature causes the particle to move at a higher speed, and the wind at space move at a higher speed. The speed is so high that the particles can escape from the sun's gravity. The importance of the sun in our life. First, the photosynthesis occurrence for most plants on Earth. Second, they maintain the temperature of the Earth's surface, avoiding extreme cold temperature for the living things. Third, natural source of light present from Earth. And fourth, the planet in the solar system retain its orbital position with the existence of gravitational force received from the sun. And these are the references and citations where I got my information from. And these are credits to my cousins for helping me. That is all from me, and thank you.